good afternoon, everybody. So, welcome to the technical breakouts. My presentation is about the future of making things, but what I'll be doing is I'll be focusing more on manufacturing and how we see the future of manufacturing and what are the strategies that manufacturers have to adopt to be successful. And then I'll provide a very broad overview of the products, the applications, the services that we at Autodesk have in manufacturing. So with that, I'll get started. Forces, the industry forces that are impacting the way that we make and design things. So, first of all, demand is both shifting and is fragmenting. So it's shifting because it's moving, the demand, the consumer class is moving more towards developing countries. So it is expected that about 1.8 billion people will enter the consumer market by 2025, and 70% of those will actually be from developing countries. So the demand is significantly shifting. And it's also fragmenting, it's breaking apart, because one is because most customers are demanding more personalization, more products that are tailored to their unique needs, and also because the characteristics of the developing markets, that they are not monolithic markets like the US or Europe. They are very diverse, and even within a country, there are many pieces of different demand. The second industry force is about the customer demand itself. So first of all, customers are demanding products that are more interconnected, that told to other products. They are also demanding products that are more customized and personalized to them. And they're expecting products that get better with time, with software upgrades. So hardware products that get better with software upgrades. And they are also demanding to be more involved in the development process. So they want to be more empowered. They want their requirements or their preferences be heard early on in the development process. The third industry force that is impacting manufacturing is volatility and uncertainty. So unfortunately, and you know this very well, we live in an environment where political, climate, socioeconomic is very unstable and unpredictable. And this, of course, is triggering some fluctuations in the supply side, like prices, currency exchanges, availability of factories that are making things very different to predict for manufacturers. And of course, there is also the demand is very volatile because customer preferences are changing more and more frequently, more rapidly. The fourth push is a push to extend product value. So, like I said this morning in the keynote, in the IoT keynote, the manufacturers are under pressure to extend the value of their product beyond the point of sale. So they are being asked to provide more and more attached services, connecting their products to the Internet of Things in order to provide predictive maintenance or optimization services. And this is becoming more and more a competitive advantage, a strategic priority for manufacturers. And lastly, the other trend that we are seeing more and more is thanks to some technologies like the cloud and 3D printing and digital prototyping, the means to design and manufacture innovation are much more available to everybody, and we call this the democratization of manufacturing. As a result, now we're seeing more startups and entrepreneurs that are actually introducing innovation better and faster than the big established companies. So if those are the forces that are impacting the industry, what should manufacturers do in order to be successful in this new manufacturing environment? First, the first strategy that we recommend is empower your customers. So give your customers a voice in your product development life cycle. Allow them to introduce their ideas, to participate in the design process. And also give them the option to personalize and customize your products. So customers increasingly will choose products that can be personalized and customized, even if it's at a premium. They are willing to pay a premium for that personalization. Increase the agility. So agility, in general terms, agility is the ability to respond quickly to changes. And I just told you that one of the characteristics of the industry is that it's more volatile and uncertain. So your ability to respond to that uncertainty is becoming also a competitive advantage. So agility is a very broad topic, and it comes in multiple forms. It could be agility in your products, to configure your products, modularize your products, or agility in your manufacturing operations, so that your plants can reconfigure more quickly to produce different products. But in any case, it's about having strategic initiatives in the manufacturing company to increase the agility. Sorry. So the other kind of sounds a little bit obvious, but master product complexity. Products are more complex now. They have more electronics, more software, more interconnectivity, more exotic materials, advanced materials. So this requires that manufacturers and product designers actually learn to do sophisticated analysis, to learn about hardware, to have more of a systems thinking, because their products are going to be connected to other products. So their mentality, their mindset actually changes, and they need to become proficient in this advanced simulation and advanced design techniques. And something that was obvious this morning, but another strategy, connect your products and build an analytical muscle. So I mentioned this morning that if a manufacturer's product is not connected, and if they are not providing attached services to those products, in a few years, their competitors will. So it's a matter of survival to actually consider connecting products to the Internet of Things and adding services like predictive maintenance, design optimization, things like that. Excuse me. And then, if you connect your products, now you have to really innovate in how you sell those products. So you have to innovate, introduce new services, new business models. So I also explained this example this morning of something that the more advanced manufacturers are already starting to implement, that is basically provide the product as a service, which that basically means allow your customers not to buy your product, but rather to subscribe to your product. So they pay a fixed amount of every month or every quarter, and in return they get the service. It could be kilowatts of power or tons of product moved. So they're subscribing to an outcome. So those are kind of 5 very general strategies for manufacturers to kind of be successful in this new manufacturing landscape. Excuse me. So let me switch gears to what is Autodesk doing? What do we have to prepare customers, to bring customers to this new future of making things? So first, this is actually from our internal industry strategy for manufacturing. The number one goal in that internal strategy is to lead customers to the future of making things. So what does that mean? Excuse me. It means that we are developing the software and the services to take customers to be able to deliver on those strategies that I just described. So, but we don't have to wait until some future. We can deliver some of the future of making things capabilities today, and I'll show you that. So starting today, these are the things that we have that are available that you could go to a channel or Autodesk and buy them today. So if you know Autodesk, or many people know Autodesk only as the AutoCAD company, or probably the Inventor company, or probably Fusion, but hopefully what I want is to give you a change in the perception that Autodesk also is very strong in other areas of manufacturing. And let me give you kind of a tour of what are the capabilities that we have in manufacturing. So an easy way to explain this is to divide products by these three buckets: design, make, and use. So in design, this slide is showing the ones in design. We have, as you can see, many tools. Some tools are for conceptual design, industrial design. Others are for 3D CAD. So this is kind of what people know as mechanical CAD tools. We are also very strong in simulation, and I'll say a few words on simulation. And underneath of all, we have our collaboration tools, PLM and Autodesk 360. So this is only for the design bucket. So I cannot demonstrate or explain each of those products, also because we don't have the time. But let me give you a taste of what they are and how they look like. So we have Fusion 360. So Fusion 360 is our newer mechanical CAD tool. And it's not only a modeling tool, a 3D modeling tool, but it's also a collaboration tool, as you can see here. It has very advanced direct modeling capabilities. It can also generate documentation, of course. But interestingly, it also has final element analysis for analysis, and it also has the capability to generate CAM, the numerical control instructions. And it also has 3D printing capabilities. So as you can see, it's not really just a CAD tool, but it's a CAD tool, and it's a computer-aided manufacturing tool, and it's an analysis tool, and it's a collaboration. So it's actually, we call it not just a mechanical CAD, but rather a product innovation platform. The other interesting thing that we have, this morning, both Callan and myself mentioned several times generative design. Well, we actually have a product today that does generative design. So there are several types of generative design. This one is one called lattice optimization. And, oops. And say, for example, that you want to optimize this joint here. This is the original joint. And you want to use generative design to optimize that particular part. So you bring it into the product that is called Autodesk Within. So you bring it into Autodesk Within. You define the geometrical connections and the boundary conditions. And then Autodesk Within will actually change the shape. It will create these little lattices of product to have the least amount of product possible and still be strong enough to support the loads. So now it's running successful analysis and optimization, one after the other. And this is the final geometry of that same part. applies a skin, and this particular part can be 3D printed. And as you can see, the result is that the stresses here shown in blue, it means they're fairly consistent. You don't see red spots or it's fairly homogeneous, which means that the shape has been optimized in such a way that the stresses are uniform everywhere. And this shape is very organic and very interesting, and it's the lightest possible one that you can get. So that's using our product called Autodesk Within, that is our current generative design product. Also, like I mentioned, over the years, we've been making acquisitions and development to really strengthen our simulation portfolio. So the result is that now we have a very broad simulation portfolio that includes capabilities to do structural final element analysis, also for architecture and steel frames, computational fluid dynamics and flow design, mold flow, which is to analyze the injection molding fabrication. And we are also very strong, probably the leaders in the market in composite materials, both the simulation and the actual fabrication of composites. So as you can see, that's a very broad simulation and very strong simulation. And some of these tools can also be executed in the cloud, so you don't need to have a very powerful machine to run them. So let me give you an example of the type of things that you can do today by combining a few of our products. This is the Fusion 360 for the 3D modeling, simulation, computational fluid dynamics for the fluid flow, mold flow for the injection molding, and Within for the generative design. So the purpose of this example is to design a mold for this part of the mixer. So this is the original mold. That's the original shape of the mold. But as you can see, by analyzing it with mold flow, the distribution of temperatures is very heterogeneous. So there are very hot spots and cold spots. So how can we redesign that particular mold to make it more efficient, both thermally, from the point of thermal, and the weight of the mold? So using mold flow, we can analyze exactly the cooling behavior of the cooling channels and come up with a shape that takes advantage of the cooling. And then by running Autodesk Within, we can generate a lattice that makes the geometry even more efficient. So this was the old design, and this is the new design. So as you can see, it's much more lighter, it's much more smaller, and the result is actually, by using this analysis, not only a 45% of reduction in weight, but more importantly, a 10% of reduction in cycle time. The cycle time is the time that basically takes to make each part, and that's very important because that increases the capacity of your injection molding operation. So this is just an example of something that is very interesting, something very advanced that can be done today with our existing products. Okay, now moving to the make part. This is probably where most people actually get surprised that we have so much going on the fabrication part. So a couple of years now, we acquired a company called Delcam that actually brought a lot of the computer-aided manufacturing capabilities to Autodesk, and they have a product called PowerMill that now is part of our CAM products. We're also very strong in design and fabrication of composites, and we also have tools to design the factory in which these things are going to be manufactured. And probably the latest addition to our portfolio is NetFab, which provides advanced 3D printing simulation capabilities. And I'll show you a screenshot, a video of NetFab. So this is a little video of the type of stuff that you can do with PowerMill. So with PowerMill, you can generate 3, 4, and 5 axis CAM. So the type of operations that you will do in this is a 5-axis manufacturing operation. You can generate instructions with PowerMill. So this is the type. PowerMill was, even before was acquired by Autodesk, it was the top CAM tool for mold and for complex geometries. Also with PowerMill, you can do robot programming. So not only for pick and place operations, but to actually do subtractive and additive manufacturing, as you can see in this video. So with PowerMill, you can generate the instructions for robots like this. And we have a very strong 3D printing capabilities. We started from the beginning of the 3D printing movement, and all of our mechanical modeling tools have the ability to print in 3D printer. So this particular example is an example of the tool that you see when you send something to 3D print. So it allows you to optimize the orientation, to set up these supporting structures, and to actually send the job to a 3D printer or a specific manufacturer. And NetFab is kind of the top tool to prepare and optimize jobs for 3D printing. So you can do things, very sophisticated things like this. This is an optimization of all these parts that can be printed in one 3D printing pass. So you are optimizing the use of the 3D printing volume to the very max with NetFab. NetFab also allows you to simulate the stresses that are occurring during 3D printing. So that is a big problem in commercial 3D printing, because the stresses, when the material cools down, it creates residual stresses that are very difficult to predict and to control. And the way that manufacturers have been doing this, they've been just printing and printing and printing and testing until they got the right geometry. Where now with NetFab, they can at least predict where the stresses are going to be, and that reduces significantly the amount of prototypes that you need to 3D print. Like I mentioned, we're also strong in manufacturing of composites. We have this tool called TruePlan that allows you to send the instructions to this tool that basically lays the fibers of the composite structures. And we're also building integrations with manufacturing as a service. So that's what MAS stands for, manufacturing as a service. So this particular screenshot illustrates the following. You have this shape, and this is inside Fusion 360, our mechanical CAD tool, and you want to send it to a manufacturing as a service to have it made 3D printed or machined or anything, or injection molded. So this, say for example, Protolabs is a service that 3D prints parts for customers. They also machine, they also injection mold it. So I'm basically saying, I'm here, I click the make button, and I send it to Protolabs, and then they ship it to you. So it's like a print button, but you don't have to have any manufacturing equipment. They'll take care of that for you. So this is, we are starting to have those integration with this type of services. And lastly, in the use group is where we do basically our IoT offerings. And our IoT offerings, if you were in the keynote this morning, I mentioned that it's Autodesk Fusion Connect, which is our IoT platform. And let me show you briefly how Fusion Connect looks like. So Fusion Connect, in this case, you have all these pieces of machinery that you are connecting. They're sending data to these dashboards. And you can have all sorts of dashboards to raise alarm or to take some action or to recommend this action. So all this is built without a single line of code. So all is basically drag and drop type of design. And it's all cloud-based. So that's our IoT platform. And lastly, remember, we're still on the things that we have today available. The one thing that came up a year or so ago, a year ago, is this Forge platform. So Forge is actually just as an API, an application programming interface for those software developers that want to develop software on top of our services. So we expose the services, the capabilities that we have developed over the years and Autodesk, things like 3D printing, configuration control, and also we provide the ability to interact with some applications like Fusion, AutoCAD, and BIM. So this is, I repeat, this is an application development platform for third-party developers who want to develop their own applications on top of our functionality. So all that is the stuff that we have available today. And let me kind of give you a taste, a glimpse of the things that are currently under development, and hopefully we'll see them as commercial products soon. So we're still working on generative design, and what this video will show is a product that is actually a project called Dreamcatcher that is basically generates many options automatically for a given design, and it helps you choose the right option. So I'll let the video kind of explain. And I apologize, we don't have sound for my computer, so we're going to be using this microphone. Okay, let's see how that works.
What if you could come up with thousands of options for a single design without drawing, all of which meet specific goals set by the designer?
So those are all the options generated.
Pick the one design that delivers on the most important criteria, the design you couldn't possibly have imagined. This is generative design, a technology that harnesses massive computing power, creating forms with precise amounts of material only where needed, achieving maximum performance while wasting nothing. But generative design can be about much more than simply turning out alternatives. Prototypes can be scanned and equipped with sensors that provide real-time performance data that can be looped back into the design process, so the object, in effect, co-designs itself. And depending on the material and method of manufacture chosen, the software can optimize the design for those choices. In its search for the optimal design, generative design creates complex forms that would otherwise be impossible to make using traditional manufacturing methods. Now with advancements in material science and the ability of 3D printers to print metal, companies like Airbus can create forms like this airplane partition panel that's half as light and just as strong. The result? Significant reduction in fuel costs and CO2 emissions. The things that have limited us in the past, software, materials, manufacturing, no longer do so. With generative design, the world can look and perform any way we want it to. This is the next stage in the evolution of design, and it's happening now.
So that's kind of what's coming under generative design. And as you probably have figured out by now, generative design is actually something really strategic for us and that we consider is very important. We truly believe that generative design is going to impact the way that we do design, because instead of us actually creating the shape for a product, we tell the computer what the constraints are and the design goals, and the computer generates the shape for you. Or in this case, we give them the design parameters, and the computer generates thousands of options, and it helps you choose the right one. So what we like to tell about generative design is moving from using the tool, the computer as a tool, to use the computer as a collaborator. And we really think it's going to change the shape of design. So we're very aggressive in generative design. The other technology that is going to impact design significantly is machine learning. And we are trying to figure out the areas where machine learning can be useful. This particular utilization of machine learning is a machine learning algorithm that looks at all the parts that you have in your repository and groups them in a way that is intelligent. So you can perform more intelligent queries, like to look for something, where have I used this part before? Do I have a part similar to this one? So it actually understands the shape and the function of the models to give more advanced queries that are not possible today. So that's machine learning. We're also looking at hybrid manufacturing. Hybrid manufacturing is basically the combination of additive, the 3D printing, and subtractive. So it brings the best of both worlds. So it's the capabilities to 3D print something really quickly with the surface precision of a subtractive. But they're usually, right now, additive and subtractive are usually done in two different machines, but there are more and more machines that can do both processes in one machine, and we want to write the software to run those type of operations. Smart robotics. So we have a group in Autodesk Research who's actually looking at ways to add artificial intelligence to robots. So the intent is to make them more autonomous, safer to use around humans. So for example, this is an example of a robot that is following the hand of this lady. So but using kind of reasoning and machine learning. So a lot of work on how to make the robots smarter, basically. Excuse me. And the other area that we are working very hard is in predictive analytics. So if you think about the IoT and the Internet of Things and the amount of data that is coming from all these machines and all these sensors, you have to have a way to extract insight and probably predict that something is going to happen or detect any patterns or things like that. So the machine learning and artificial intelligence techniques have a lot of potential in this area of predictive analytics, and we are actually starting to incorporate predictive analytics capabilities in our IoT product, Fusion Connect. And last, we're looking very closely into the potential utilizations of virtual reality and augmented reality. This is an example of a collaboration we did with Microsoft with their augmented reality device called the HoloLens. And it was basically to experiment ways to use augmented reality to have a collaboration, a design collaboration. So those were kind of the areas that we are pursuing. Something that we're also doing is that we are kind of re-architecting our capabilities from all of our products into what we're calling a single product innovation platform. So in this product innovation platform, which is going to be called Fusion, we have Fusion at the center with all the data about the products. And then we have the design capabilities, the manufacturing capabilities and the IoT capabilities around that data center. So for example, our generative design capabilities will be in the design group. Our 3D printing and CAMP capabilities will be here. And then our connectivity, our IoT capabilities will be around the use area. So, I mean, this is just a very conceptual diagram, but we are reconsidering and re-architecting our products and our capabilities to kind of deliver in this form of a platform.
We're entering a new era of manufacturing, an era of massive change and disruption, an era in which you've got to evolve to stay competitive, where the key to success is innovation. Today, the future of making things is forcing product designers, developers, and manufacturers to rethink the way they design, make, and monitor products. Why? Because consumers expect smarter, connected, and more personalized products than ever before. Autodesk is embracing this new era of manufacturing and creating the solutions you need to stay competitive. Introducing Fusion, a cloud-connected product innovation platform. It's not just a CAD or CAM tool, not just a PLM or IoT tool. It's all of these and more. It's a true SaaS product development platform that allows you to rapidly create generatively designed products, metal 3D printed products, products connected to the world around you. Fusion brings together a set of apps that helps you design the products of the future that are optimized to perform as great as they look. That helps you make products using advanced manufacturing techniques to achieve higher quality and lower costs. That helps you understand how customers use products. Gathering real-world data and closing the loop to inform future innovations and shorten the development cycle. Fusion was designed to run entirely in the cloud. There's no hardware to buy and maintain. No costly upgrades, and your data is accessible anytime, anywhere. With Fusion, industrial machinery manufacturers can evolve product lines to incorporate IoT, creating new revenue opportunities and service capabilities. These new product lines include sensors and electronics that collect real-world data. Data that is based on usage performance that feeds new features, functionality, maintenance, and product optimization. With Fusion, you can detect patterns, make isolated or full-scale adjustments to save time and money for you and your customers. You can make more informed decisions based on real-world metrics collected from your products. With Fusion, you can achieve competitive separation by leveraging operating data from your products in the field, gaining insight to provide higher levels of service, customization, and design optimization. Get ready for the future of making things. Innovation starts today with Fusion by Autodesk.
So obviously this is a marketing video, so it shows everything is kind of mocked up and it's not real, but it does show our strategy towards manufacturing and how we want to integrate this, and we're actually working on that right now. So that's the last slide. Hopefully what I was able to convey today is kind of our view of where the manufacturing industry is going, our picture of the future of making things, and hopefully I gave you a very high-level idea of the products that we have today and the products that we are developing to take you to this future of making things. So with that, thank you very much, and have a good rest of the day.